Welcome back to class. We want to use this section to conclude the rationalization of SURDS. Generally speaking, mathematically, in a fraction, we don't expect to have a square root as a denominator. You recall what a fraction is. A fraction must have a numerator all over a denominator. This one here on top is called numerator. Okay? While this one here is called the what? Denominator. Now, whenever you have a root under this denominator, if it's a single root, not in an equation way, what we do is called rationalizing. What does rationalizing mean? It's just like using a unity, 1, to multiply both sides. Let's use this first one as an example. Let's solve this now. You know, this is 10 root 2 all over root 5. Mathematically, I said we cannot have square root as a denominator. So what do? I do what? I rationalize. I do what? Rationalize. So in rationalizing, the whole idea is to eliminate root. So I will use this denominator to multiply both factors up and down. It's just like saying 10 root 2 all over root 5 multiplied by 1 root 5 all over root 5. You know root 5, this if I cancel it's like I'm using 1 to multiply it. And then you multiply by 1, you still remain in that way. So when I do that, later I do this, I have rationalized. So what do I do? Then what I will have will look like this. 10, 5 times this will give me root 2 times 5. My numerator becomes 10 square root 10. Okay? While my denominator becomes square root 25. And what is the square root of 25? That gives me 5. Is that taken? 5 can go in 10. That gives, so my answer becomes 2 root 10. This is my final answer. Now let's look at this second equation. This one on its own is standing on its own. The number 2 is standing on its own. I write that 2 root 2 minus 6 has a denominator that is square root. So I rationalize that. So I have 6 root 3 multiplied by root 3 over root 3. Right? Then I move to the last part, plus 3 root 27. I rationalize it again, so I have root 27 all over root 27. Okay? So what do I do next? This maintains how it is, so this is 2 root 2 minus 6 root 3 all over root 9, because 3 times 3 is 9, right? Okay, minus 3 root 27 all over 27 square in root. This is already a perfect square, so I continue. I have my 2 root 2 minus 6 root 3. What's the square root of 9? 3. Minus, I can further split this 27 so I can get an easier value. So I can say that this is 3 square root of what? 9 times 3. Is that taken? All over. The square root of the square of 27 will give me 27. So I continue. I still have my 2 root 2. This can cancel this. So that gives me 2. So this becomes 2 root 3. Are you there? So minus 3 can cancel here. This will cancel it. This gives me 9. So I have, what's the square root of 9 here? 3 root 3 all over 9. Right? This will further divide this. This gives me 3. So what I have will now be 2 root 2 minus 2 root 3 minus root 3 over 3. So minus 2 root 3 minus 1 over 3 root 3 will give me 2 root 2. This over this, the LCM is what? The LCM is 3. How many one can go here? 3. I have my minus. Opening it up. 3. 3 times 2 gives me 6 root 3 minus 3 root 3. It will give me 2 root 2 minus 3 root 3 minus 3 root 6 root 3 minus 3 root 3 gives me minus 9 root 3 over 3. Okay? So that continues. It will give me 2 root 2. This can cancel. That gives me 3 root 3. This will be my final answer in the equation. Okay? Salt conjugate, if this is a salt, this is a denominator in an expression. The conjugate of that denominator will be, all you need to take the sign here, this becomes minus, that's the conjugate. And by the time you expand the denominator, this and this, this is what you are going to get. Let me show you how. For instance, if I have 2 all over 2 plus root 3, and they say the question says simplify, for instance. This is the question. It says simplify this. Because I have told you earlier that we cannot have a square root as a denominator, what do I need to do? I do what we call conjugate. Are you getting me? So if I will now have 2 all over 2 plus root 3 multiplied by 2 minus root 3, which is the conjugate, all over 2 minus root 3. Are you there now? Okay, what is happening here? It means I must expand this and this like difference of 2 squared. So I have 2 plus root 3, bracket close, 2 minus root 3, bracket close. How many? Now, then this one, I will use this to multiply everything here, 2 minus root 3. Is that clear now? So what do I do? What do I have? I use this, so I will say 2, bracket open, 2 minus root 3, bracket close, plus root 3 here, this root 3 here, multiplying everything here, 2 minus root 3, bracket close. This one, if I open a bracket here, I will be having 4 minus 2 root 3, 2 times this 4 minus 2 root 3. So I will still need to expand the denominator further. This times this gives me 4. This times it gives me minus 2 root 3. Plus root 3 times this gives me plus 2 root 3. And plus times minus gives me minus. Then root 3 times root 3 gives me 9. Okay? Where I have my 4 minus 2 root 3. So I continue. 4 minus 2 root 3 is still here. My denominator. Minus 2 root 3. Cancel that minus 2 root 3 plus 2 root 3 gives me 0. You know I told you minus is you are owing. This you have. So when you pay, you have 0. So what will be remaining here will be 4 minus 3. So my final answer therefore will be 4 minus 2 root 3 all over 1, which is saying 4 minus 2 root 3. That is how conjugation is all about. So let me give us a classwork that you will come back to give to answer for me. So classwork. So feel free to solve and submit at the comment section. And if there is any error, my team will check and we will solve it correctly for you by the back channel. So let's look at this question. 1A. Simplify 5 all over root 3. Okay, and B, simplify 2 plus root 3 all over 5 minus root 2. So in this case, I expect you to conjugate. In this place, I expect you to what? To rationalize. So when you do that, you will get your final answer. So make sure you try it. All I need from you is to make sure you share, you like, you comment, and share to all your contacts. See you in the next video when we shall be treating a new topic in the JAM syllabus series.